We need to look at forces applied at an angle. We have a 12 kilogram object pulled across the floor by 50 newtons of force at an angle of 37 degrees above the horizontal with an acceleration of 0.7. We're looking for the applied force, the frictional force, and the coefficient of friction. As always, the first step whenever you do these kinds of problems is to first solve for your triangle. So we need to solve for the x leg and the y leg of our triangle. The y leg of the triangle is always the force in the y direction. Let's delete that. Let's say force in the y direction. Now that is always going to be the sine of the angle. So sine of 37, and sine equals opposite, so that's the y leg, over the hypotenuse, which is 50 newtons. Punch that in your calculator. Sine 37 equals y over 50. You end up with the force in the y direction to be equal to 30 newtons. Now, next thing you need to do, next we need to solve for our force in the x direction. So force in the x direction is always going to be cosine of the angle. So cosine of 37, and cosine is adjacent over hypotenuse, so x over 50. Plug that into your calculator, you should find out that the force in the x direction is equal to 40 newtons. Now, whenever you solve for the x, that is your applied force. So this time we're pulling this object, so our object is going to move to the right, and that would make our applied force our x leg of a triangle. So force is equal to 40 newtons. That's the first thing they asked me to solve for, was the force. So now I know the force is 40 newtons. We're still going to have to solve for the friction at some point. Friction always opposes the motion, so friction will be to the left. Since my applied force is to the right, friction is to the left. We'll go ahead and put that in there so we keep that. That's step one. Always solve for parts of the triangle. Step two. Always solve for the normal force next. Now, the force of gravity next. The force of gravity, you figure that the same way every time. Mass times gravity. So in this case, we have 12 times gravity, 9.8. So our force of gravity is going to be 117.6 newtons. Okay. We know our force of gravity then is 117.6. That's step two. Always find the force of gravity. Step three. Next thing you need to do is always solve for the normal force. This is where things get tricky. The normal force is equal to the force of gravity. But this time we're pulling. So remember, when we pull, we subtract the force in the y direction. Well, that tells me it's 117.6, the force of gravity, minus the force in the y direction, which was 30 newtons. So the normal force is equal to 87.6 newtons. All right. Remember, when we pull, we subtract. If we were to be pushing this object down, then we would add the F in the y direction right here in our normal force equation. Okay? That's why it's always important to solve for the triangle first. Now, let's see what the problem's asking us to solve for. We need to do those three steps first every single time. The triangle, the force of gravity, and the normal. We want to find the friction and the coefficient of friction. Well, by using Newton's second law, I know that force minus friction is equal to mass times acceleration. Well, I know the force, that was the x leg of my triangle, 40, minus the friction is equal to the mass, 12, times the acceleration of the object, which in this case was 0.7. They told us that in the problem. Solve for friction, and you should come up with the small f, or friction, to be equal to 31.6 newtons. I'm going to go ahead and add that into my diagram because I can't stand to have boxes that are empty. So 31.6 newtons And I want to add that in up here because they asked me to find it, so 31.6 newtons. Now I need to find the coefficient of friction. Well, just like what we did before in the horizontal problems, I know that friction is equal to the coefficient of friction times the normal. Well, friction was 31.6, I just found that, is going to be equal to the coefficient times the normal of 87.6 newtons. So really, I'm just dividing 31.6 by 87.6. And I find out that my coefficient of friction, U, is equal to 0.36. There's no unit for the coefficient of friction. The coefficient of friction is a ratio to tell me how frictionless or friction full the surface is. Add that in here because they asked me to find it. And that's it. Don't forget Newton's second law and the friction equation.